Hi, in this video I'll explain the interfacing of an integrated circuit called 8255 with 8051 microcontroller. 8255, it's basically an integrated circuit which we use it along with 8051 for various applications. Let us see more in detail. So 8255 is basically it is used to expand the ports of 8051. You know that 8051 has how many ports? Four ports. So when the ports of 8051 is not sufficient and you want to expand it further, then we can use this 8255. 8255 is basically it's called as programmable peripheral interface. So using this, we can connect many peripherals to the 8051. So 8255 will act as an intermediary between 8051 and the peripheral in a way that expands the ports of 8051 so that many peripherals can be connected to 8051 parallelly. And what is 8051 basically? As I told you, it is basically an integrated circuit. It has three 8-bit ports, namely port A, port B, and port C. All are 8-bit port. And port A is ranging from PA0 to PA7, and port B is ranging from PB0 to PB7, and port C is ranging from PC0 to PC7. So like this, we have three ports in 8255 peripheral interface. In addition to that, it has many functions like read, write operations, and also it has few data pins that is ranging from D0 to D7. That basically a 8-bit data pin, and also it has have an ability to reset. Then in addition to that, it has two address lines A0 and A1, and also we have a separate signal called chip select, which is used to select a programmable peripheral interface. So this is the IC that I am talking about. This is basically a 14-pin integrated circuit. You can see that you have the port A arranged here, and you have a port B arranged here, and you have a port C arranged at this place. Then you have a data pins, then reset is there, chip select, read, and write operations also it is included in this read and write operations. Okay, then also you have address pins A1 and A0. So this particular thing can be easily addressed by using two address pins. A simplified block diagram of 8255 is it is a block having two interfaces. One is towards the system side, that is towards the microcontroller side, and other side is a peripheral bus where you can connect the peripherals to these ports. Okay, so port A, port B, port C. So probably when you say that in a microcontroller you have only one port is left after using off or all other uh, ports for some other applications. Then by using 8255 you can expand that one port into a three ports, and you can connect some three peripherals to it so that parallelly we can function in such a way. I basically use it to expand the 8051 ports. So as you proceed further, we will get to know how to use these ports and how it's actually expanding the ports of 8051. Then you may think that it is little complicated to understand, and all of a sudden a new peripheral device is introduced here. It's nothing to worry. It is as simple as the external memory interfacing. External memory interfacing, we have studied with the 8051 microcontroller, where we use the ports for carrying the address and data, and also we had some latches in between the microcontroller and the memories, and also there are read write pins, chip select pins. So the same concept is going to be used here for interfacing 8255 with 8051. Hope this clears most of your doubt about how to use 8255. Just remember how to interface the external memory. The same concept is going to be followed here. Okay. Then, in order to select the ports, no, we have to use specific control words here. So let's see how to select the ports. You can see that there are three ports: port A, port B, and port C are there. Okay. So to select the ports, we use the address pins A0 and A1, A0 and A1, and also there is another pin called CS, which is called a chip select. Chip select means in a microcontroller, and in conjunction with the microcontroller, you will be using many devices. Sometimes you may be using your external memory, sometimes you may be using your 8255 or some other peripherals you may use. Okay, so in such cases, whichever the circuit that you are concentrating on, then what you have to do, you have to select the corresponding chip. Okay, so that is why we call it as a chip select. So that's what we call it as a chip select. Okay, now, so if the address bus is having a value 00, that means the port A can be selected, and if it is 01, then port B will be selected. 10, port C will be selected. So these are the details has to be given by the 8051 microcontroller in order to select any of these ports. 00 port A, 01 port B, 10 port C. And also in addition to that, another important thing is there is a control register. There's a control register inside this programmable peripheral interface, and in order to select the control register, we can use the value 1 1 for A0 and A1 respectively. Then there is a chip select. Okay, if you want to use your A255, the chip select, its active low signal, so that should be set to 0. If it is 1, then 8255 is not selected. Got it? So the chip select you may be using for some other device also, that particular device will get selected. Okay, so when you want to select the mode port, you have to use these address pins A1 and A0 respectively. Okay, then also now when you say the 8255 is a programmable peripheral device. Okay, so it supports the various modes as well. Okay, so what are the modes of operation of 8255? The first mode is called as a mode 0. Mode 0, it is called simple in out mode. As the name serves, it basically used for input and output purpose. So any of the ports A, B, and the C, the port C is divided into two parts, CL and CU. So A, B, CL lower and CU, C upper. That means the port C lower, port C upper can be programmed as input and output. Input and output. So like this, we can use the ports for a simple in-out operations in mode 0. Then all bits are out or all are in. So at a time, we can use all the bits are as an output or all the bits as an input port. Then mode 1. The mode 1, the port A and port B can be used as input or output. Port A and port B can be used as input or output ports with handshaking capabilities. So when you connect probably a printer as a peripheral or a LCD device as a peripheral to the 8255, the 8255 can communicate with the peripheral. Got it? Whether the printer is empty, printer can receive the signal. Then printer can say that, yes, I am ready to receive the signal. Can I send the data? Yes, you can send the data. So like this handshaking capabilities are there with 8255. So that can be achieved by using mode 1. And in mode 2, the port A can be used as a bidirectional input and output with handshaking capabilities provided by port C. Okay, that's about port 2. Then port B can be used either in mode 0 or in mode 1. So when you use mode 2, the port A can be used as a bidirectional in-out port with the handshaking capabilities that provided by port C, and port B can be used either in mode 0 or in mode 1. So like this we can decide the mode. Then the next mode is called BSR. It's called bit set or reset mode. Bit set or reset mode. So here only the individual bits of port C can be programmed. So it means the complete port C cannot be used. Only the individual bits of port C can be programmed. Okay. So what we do, we use particularly a control register. We use a control register like this. Got it? So this control register, it is used to control the it is used to control the operation or control the selection of the modes and selection of ports in 8255. Okay, so it's grouped into two groups. Group A, it consists of the mode selections. Okay, generally for mode selection and mode selection of the ports, then for port A and port C upper. Then group B, it is for mode selection of uh, B port and for the port C. Good. Like this, it is grouped here. Based on this, based on the requirement, we can write a control word into it. Okay. So now here, if you look into it, so when you want to use in-out mode, this D7 bit will be set to high. D7 bit will be set to high. So we are not going to discuss the BSR mode here. We are just confining ourselves only to the in-out mode. Okay. So D7 will be set to high. Then D6 and the D5 are used to select the mode of 8255. I used to select the mode of 8255. What are the modes of 8255? Mode 0, mode 1, mode 2, and bit select mode, isn't it? Okay. So by using this, we can specify whether it is mode 0, mode 1, or mode 2. Okay, that we can specify it here. Then D4 bit, it is for configuring the port A. Port A, if you want to use as input, you will be giving 1 here. If you want to go to use output, it will be an output here. Similarly, D3. D3 is for port C upper part. Okay, upper part. That means between 7 and 4 down, 7 down to 4. So if you want to configure that particular part as an input, then 1. Otherwise, it is 0. Similarly, for D2, D2 it is mode selection of 0, that is for mode 0, and 1 for mode 1. For what are the ports? Port B and port C, lower part. Similarly, input and output also can be configured by placing 1 and 0 respectively. So like this is what we call as a mode selection of 8255. Mode selection of 8255. So we have discussed so far what is an 8255, what are the ports of 8255, and how to select the ports, and also how to select the modes of operation for 8255 and for the ports as well. Okay, with this understanding, now let us go on to discuss the simple in-out programming concepts. So we'll take no find the control word of the 8255 for the following configuration. As I told you, to use 8255, we have to use a control word. We have to use a control word. Okay. What is the first one? All the ports of A, B, C and C, all the ports of A, B, and C are output ports. Output ports. That is mode 0. Mode 0. Okay. Then what should be the control word? Okay. What should be the control word? Okay. That is P. Next one is PA is input port. The next configuration is PA is equal to input port. PB is equal to output port. The port A is going to be an input port, then port B is an output port, then port C lower is an output port, and also port C higher is also an output port, isn't it? Okay. So here comes our basic detail, isn't it? So what do you want to configure? What do you want to configure first? All the ports of A, B, C in output mode with mode 0, isn't it? So it's basically an in-out mode, isn't it? So the D7 will get one value. D7 will get the value 1, isn't it? Then the mode selection. What is mode selection? Mode selection is mode 0. So mode 0. Then this will be 0 and this will be 0. Then port A. Port A, how are you going to configure output port? Then it should be 0. Then this should be 0 here. Okay. Then port C. Port C, no, it is also all or it's output mode only. So port C also, this also 0 it's going to be. And port, then the mode selection is going to be mode 0 here, even for the next group. Mode 0. Then this is what port B. Port B also output, so this also will be 0. Then port C, this also will be 0. Now, then tell me what will be the control word that we are going to write here? 1, 0, 0, 0, 0, 0, 0, 0. So that means what? Very good. The control word is what? 80H. 80H is the control word, isn't it? Okay. Similarly, for PA is input, that is port A is input, and all other ports are output. Then what do you have to do? So here it is 1 in out mode, and these two modes again it is going to be 0. But here D4 is what now? Yes, it should be 1 because P port A is going to be your input. So it will be 1. Then all these are going to be output. So it will be 0, 0, 0, 0. Then what is the control word that we have to give? Very good. It's going to be 1, 0, 0, 1, 0, 0, 0. What is that? It's nothing but 90H. 90H. So like this, first we have to find the control word of 8255 for any given configuration. Okay. Okay. Then let's see how to connect 8051 with the 8255 programmable peripheral interface. First thing is what you have to do. We have to send a byte to the controlled register of 8255. So we have seen just earlier, right? So that is the control register. So to the control register, first we have to send a byte. After sending it, what you have to do? Then we have to find the port address assigned to each of the ports. Port address assigned to each of the ports. What are the ports? A, B, and C, and the control register, isn't it? So using this, we can get it. As I told you, now does this diagram look similar? Because already we discussed about external memory interfacing. The same concept only we have used here. And now instead of a memory, what do we have? We have 8255. So this is a basic configuration how an 8051 is connected with 8255 programmable peripheral interface. Okay. Okay. Now see here. This is a microcontroller. This is a microcontroller. So microcontroller, what are the ports of the microcontroller we are using? You see that. So here we have port P0 and we are using port P2. Then also we are using the few pins of port P3. That I'll come to that later. Then what do we have? On the other side, you have 8255. 8255 is a separate part. So it has three ports PA, 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 PB and PC. Then also it has what it has the read, write, chip select, address pins, then data pins, and also you have a reset. Also you have a reset. Got it. So like our external memory interfacing, here the port P0 to P7, it is used to carry the lower byte of the address and also the data. You know the time multiplexing concept is there. So whatever comes first, that will be an address that will be stored in the latch. Okay, then in this only A0 and A1 we are going to make use, and that will be given as an address inputs to the 8255. For what purpose do we use this A1 and A0? Very good. So we are using this A1 and A0 for selecting the ports. So based on the inputs that we give for this A1 and A0, we will be selecting PA or port B or port C. And also in addition to that, there's another thing called a control register, isn't it? So the control register are also going to be selected based on this signal that we give it to A1 and A0. Then also you can see that parallelly from here we are going to take the data inputs into 8255. So whatever that microcontroller that's going to be it's going to send through these data pins, A0 to A7. That is AD0 means it will carry both address and data. When it's carry the address, we enable this latch, the address will be stored. When it is carrying the data, we disable this latch and straight away we bypass this signal to the 8255 data pins, and that gets connected here. So bidirectionally the data can be passed from microcontroller to 8255, and also between 8255 and microcontroller the communication can be established. Then also you can see that there is a P2.7 pin, that is we are using it for carrying the chip select signal. Okay, understand that. So whenever we use the external memory, generally we use 16-bit address, isn't it? So the lower byte address is carried by AD0 to AD7, that is carried by what? Port P0. Then other address is carried by, the higher byte of the address is carried by port P.0 to port P2.7. Together the 16-bit address is formed here. Together 16-bit addresses formed here. Okay, so in this which port which pin we are using? Only pin address 4 we are using, address 14 we are using as an input for the chip select. And also this P3.6, it's for a writing operation, and P3.7 for a reading operation. So by using the writing operation we can write the data into a we can write the data into the 8255. By using the reading operation we can read the data from the 8255 into microcontroller. And also by using ALE we can enable this latch for storing the address, isn't it? So these are the two things that you have to do. First thing is what? You have to send a byte to the control register of 8255. Then you have to find the port address assigned to each of the ports. So the connection comes first. First we do the connection, then we do the programming part. Then we do the programming part. Okay, so that's a very basic thing that you can if you remember the memory interfacing, then this connection entire thing will be very easy for us to do it. Okay, yes. Now let us take one simple example here. Okay, the example is find the in-out port addresses. Find the in-out port addresses assigned to ports A, B and C under the control register. Okay, now for this given configuration, for this given circuit, so the previous diagram only that it is again it is presented here. So here what is the given? The same no, we use the 16-bit address here, and 8-bit data lines are there, and using 8-bit data line we can write the data into 8255 control register, isn't it? So that's what we have to find out. So what is the input port addresses assigned to ports A, B and C and the control register? What is being asked here is you are using a microcontroller, and how many bit of address lines are used? 16-bit address lines are going to be used. So when you use 16-bit address lines, what output the microcontroller has to do so that it can select the port A, port B, port C and the control register, and the control register. Okay, so it is very simple thing that you have to understand. You can see that here. So we are using 16-bit address, isn't it? You're using 16-bit address. In the 16-bit address, which pin we are using? Yes, A15. We're not using it, so it can be of any values. It can be of any value. Then A14 is being used, isn't it? A14 is being used, and also you can see that it is a, what is it? Active low signal. So a buffer is placed here. Sorry, an inverter is placed here. So that will give a complement of A14. So we have to set this to 1. If I set to 1, then this will be 0 here. So that is set to 1. Then all other, no, we are not connected here. So all other can be anything, isn't it? And what is other the important thing is the A1 and the A0, isn't it? So for what purpose we use this A1 and A0? To select the ports. If it is a 0 0, port A will be selected. Port A will be selected. Got it? Then what should be the address given to the 8255? What should be the address given to the 8255 from 8051? Look into it. What is that here? This is 0 1 0 0, isn't it? So what is this? This is 4. This is 4. Remaining all can be of anything. So when you replace everything by 0, it would be 4 0 0 0. So 400 H hexadecimal number can can select the port PA, can select the port PA. So from microcontroller, for this given configuration, if you give the control, if you give the address 400H, it's going to select port PA. Got it? Similarly, if it is for port B, what you have to do? Yes, same connection is there. Only thing is the address we have to change 01. 01 if you change, it will become 4001H. So the port B can be selected, isn't it? Then 14, again the connection remains same. So 10 for port C and 11 for control register, 11 for control register. So if our given configuration, what are the addresses that we have to use here is, to select port A we have to use 400H, then to select port B we have to use 4001, and to select the port C we have to use 4002, and to select the control register we have to use 4003, isn't it? Okay. Next, what we have to do, we have to program the 8255 for ports A, B, and C to be output ports, isn't it? You have to program the 8255 for ports A, B, and C as an output port, isn't it? So this is only for selection of the ports. Please understand that. The next, what you have to do, you have to configure the ports. You have to configure the ports. Okay. So in order to configure the ports, what do? We use our control word here, isn't it? Okay, so what do they say here? Program the 8255 for ports A, B, and C to be an output ports. So all our output ports it's going to be. Then what would be that? So it's going to be in in-out mode. So this will be 1. Then in-out simple in-out programming mode. So it's going to be mode 0. So this also will be 0 0. Then all our output ports. So this also 0. This also 0. Then mode here also this is 0. Then here output also 0. Here output also 0. Then what would be the controlled word? That's the word that is required here. Absolutely, that is 80H is the control word that is required here. If we pass this control word, then we can configure the ports. If you pass this control word, okay, you can configure the ports. If you pass this value through the microcontroller, then what we do, we can select the ports. Can select the ports. Got it? Okay. So with this, it will help you to have a good understanding about what is 8255 and how to interface an 8255 with an 8051, and further how to connect a peripheral to it, and how to configure the ports, and what are the addresses, and how to generate the addresses for the given configuration, and also how to generate a control word for configuring the ports. Okay, thanks for watching.